Its generators are turned by steam, produced by heat released by unleashing energy which binds together the nuclei of atoms. In nuclear power plants, uranium, seen here as it looks made into a fuel pellet, is used as fuel instead of the coal, oil, or natural gas used in conventional power plants. In order to produce heat, the uranium atoms in the fuel must be split. This process begins when a neutron collides with the nucleus of a certain kind of uranium atom, splitting it apart. This splitting is called fission, and when it takes place, part of the energy that held together the nuclei of the uranium atoms used as fuel is released as tremendous amounts of heat. In the process, still more neutrons are released from the splitting uranium nuclei. These, in turn, go on to split even other uranium atoms, thus releasing increasing amounts of energy. This ongoing process of splitting of atoms and thus releasing energy is self-sustaining as long as there is fuel remaining, and it's called a chain reaction. Here is a demonstration of how a chain reaction works. Each of these mousetraps is set and loaded with a ping-pong ball. One ping-pong ball is thrown into the container housing all the mousetraps. That one ball starts the chain reaction. As mousetraps are triggered, more ping-pong balls go flying. Within seconds, most of the traps have been triggered. Over the years, scientists have learned to use nuclear reactors to harness chain reactions and put them to work producing large amounts of electric power. In a nuclear power plant, the heat from the chain reaction that goes on in the reactor's core is used to make steam. This steam is then used to spin a generator, which produces the electricity the plant supplies its customers. Today, fission, or the splitting of atoms, is the only way in which we can drive nuclear power plants. In the years to come, however, scientists hope to harness yet another kind of nuclear reaction. It's called fusion, and it's the opposite of fission.